There are days in space science when all the predictions, simulations, and cautious expectations simply fall apart. Today is one of those days. Interstellar Object 3I Atlas has shifted again. And this latest deviation is not small, not ambiguous, and not within the known margins of error. Whatever this object is, it is not behaving like a typical cometa, not behaving like a standard interstellar fragment, and certainly not obeying the patterns traditionally associated with gravitationally driven bodies passing through the inner solar system. The update came through less than 40 minutes ago from several independent observation pipelines, ground-based surveys, automated ephemeris generators, and one orbital relay. All show the same thing, a directional change, slight at first but unmistakable when compared to the predicted trajectory. A movement that is too sharp to be random noise, yet too smooth to be a fragmentation event. The displacement is subtle in angular terms, but in interplanetary geometry, even a fraction of a degree means tens of thousands of kilometers of difference, and that difference is widening. This is now the fourth significant deviation recorded since late September and the second in just the past 72 hours. And each time, the explanation becomes harder to reconcile with any known natural process. The shift today appears correlated, at least in timing, with a surge of charged particle activity from the Sun, including the remnants of a coronal mass ejection still dispersing across the heliosphere. But correlation does not imply causation, and the nature of this shift does not match the effects expected from ion pressure or asymmetrical outgassing. There is no sudden brightening. There is no tail burst. There is no rotational plume releasing new material in one direction. Instead, the coma remains nearly uniform and unusually featureless, with that persistent sunward anti-tail the signature that continues to puzzle every researcher who tries to model it. Right now, 3I Atlas is approaching its minimum solar elongation from Earth, meaning it is nearly lost in the glare of the Sun. Only spacecraft and off-axis observatories can still track it, and even those are limited. Earth-based astronomers are effectively blind, and the timing could not be worse. A major government freeze has paused several public-facing data channels, creating one of the most inconvenient gaps in transparency right when the trajectory of one of the strangest objects ever observed is actively changing. Despite this, a few instruments have continued operating. Several Mars-orbiting spacecraft and rovers have been gathering data as 3I Atlas sweeps through its nearest approach to the red planet. And, yesterday, a sequence of images taken from the Martian surface showed a fast linear streak cutting across the sky, persisting across multiple frames. The orientation does not match star motion elongation. The exposure smear aligns with the object's velocity vector, not with the rotation of Mars. This strongly implies a genuine transiting object moving at extremely high speed. Nothing in Mars' orbit matches the position. Nothing in Mars's known satellite paths matches the altitude. And nothing else in that part of the sky is expected to move in such a straight, rapid line. Given the timing, direction, and the angular velocity, the simplest hypothesis remains that this was 3I Atlas itself. And if so, the perceived brightness and motion suggest a nucleus minimally 5 kilometers across, potentially larger, that would make it one of the biggest interstellar objects ever successfully imaged from within a planetary system. The latest shift complicates everything. When an object of that mass alters direction without fragmentation, without visible outgassing asymmetry, and without measurable drop in velocity, something unusual is happening. Models attempting to fit the new trajectory require either a highly uneven, deeply buried jet of sublimating material that somehow produces thrust without generating a visible plume, or an internal structural process that does not resemble typical thermal outgassing at all. The earlier hypothesis that the September 25th CME might have disrupted the coma structure still holds, but the timeline has not matched expectations. There has been no radical expansion of the coma, no major rearrangement of the polarization patterns. Instead, the object seems almost unaffected by the impact except perhaps for the slow, subtle drift we continue to detect. The older images, such as the optical band observations from Namibia around September 25th, still show the same eerie green glow and the same anomalous sunward density tail. The shape remains compact. The brightness remains oddly stable, and the inclination of the orbit remains aligned suspiciously close to the ecliptic plane, far more so than the known interstellar visitors observed so far. That alignment has raised eyebrows since early July. But now, with each additional deviation, it is raising far more than eyebrows. As of now, we have a timeline of deviations, a position anomaly after the CME impact, a minor correction on September 27th, a larger drift detected October 2nd, and now another measurable shift today. At this point, comparing the predicted path to the actual path is like overlaying two maps that no longer agree with each other. This is not chaos, but it is not the behavior of a passive icy body either. Mars orbiting instruments should be sending down more data soon, at least from international agencies not affected by the shutdown. The European Space Agency scheduled multi-instrument observations today using Mars Express and the Trace Gas Orbiter. These are critical because 3I Atlas is temporarily closer to Mars-based instruments than to anything else in the solar system. If any mission captures a high-resolution view of the nucleus, it will be one of these.